Hey everyone, this is Kim Delatorre. This is my ACTE 651 Capstone project. I started my project with a common misconception that light can only be reflected from shiny surfaces like a mirror. Students may also believe that an object cannot absorb and reflect light, it must do one or the other. So there was two parts to my activity. One was to build your own solar heater, make observations, collect data, and the other part was to do a heat absorption simulation. It involves a Gizmos activity. If you haven't tried that website yet, it's on Explore Learning, and a student page that goes along with it. So for the solar activity, you'll see it attached. It has the instructions on how to build one, and then there's a data chart that they can use to collect, but essentially it'll look like this. And then their Gizmos activity, it takes you to the website. I have the subscription through my school. They do have some free activities, but it does kind of give you like a 5-minute preview if you click on the link for it. The other link I provided was the Student Gizmos page, which is just the handout. This is one that came with it, but I just modified it to something that was more student-led, that they could make their own observations, create their table, and make their data tables that way. Some of the tables that were in the Gizmos I did keep to kind of guide them along, but overall they were mostly taking their own observations and taking down their own notes. So going back to this, in part one, you start with just your basic materials, aluminum foil, either a 1 or 2 liter bottle, and then an aluminum can and the cardboard box. I used like an old box. I actually used 2 boxes to connect them together to get all the cardboard that I needed. Next, you start looking at where or how you're going to place it. So your can should be painted black, and it's going to go inside of the plastic bottle. I have a bottle that's already kind of pre-made. By the way that it's cut. It's made for science experiments, but with a simple 2-liter bottle, you can cut tabs to make sure that it closes tightly. Then you would place the thermometer inside to make sure that you're getting your temperatures recorded. So this is after I put the aluminum foil. I just taped it to anywhere that light would catch. So I made a nice wall and the bottom base of the cardboard box just to make sure that any light that hit the aluminum foil would reflect onto the can. So it essentially, you place it near the sun, and the shadow in the back is acting like a solar panel that continues to reflect. And then finally, it'll look like this. You'll have the thermometer inside the can, and you're supposed to record temperatures every 5 minutes to observe any changes as the light is being reflected and absorbed. So the observations that the students would see is that the thermometer shows a significant increase in the water temperature from inside the can. The black paint obviously absorbs the light energy. It builds up and produces the heat on the surface of the can. And then that surface energy is transferred into the water, which then causes the water molecules to vibrate rapidly, which is what is heat. So that would be more of the explaining part for students. And here's part 2 with the Gizmos. I kind of just did a little screen recording where you can see, you can change the different materials, whether you want white brick, green brick, blue brick. You can change the color of light that is hitting it. So then they can tell whether or not the light is being absorbed or reflected. And then you can also manipulate the temperature and observe that to see how the different bricks, if you hit play in the corner, depending on the brick, it'll either heat up more or heat up less. So that's kind of all that it's shown there. And you can always reset it and continue playing with it. So I think it's a really great activity for students to really just explore that piece to see how different materials or different colors are using up the light. Okay, so they should conclude that the correct concept is that all objects absorb and reflect light, and just to different degrees. Our ability to see objects depends on the reflection of light. This project with the STEM perspective, I think, is more science geared. However, it does incorporate other disciplines like the technology piece. They're using their computer, they're building, and they do have to take data and notes with their temperatures as they observe. In the table of 6.2, I had several of the science practices and the math practices starred because it did encompass a lot of things. Students continually ask questions about why certain colors are absorbing and how they're reflecting. They created their models and they're actively engaged in what they're building and as they're doing the simulation. In the 6.3 with teachers' behaviors, it does integrate to real life applications because students start by seeing whether or not their dark colored shirts or light colored shirts would heat up in the sun. They are creating an experimental design, looking at different standards that match with the activities. The teacher does ask guiding questions, but the students also ask questions in their discussions. And then the formative assessments are more just the teacher observing whether or not their misconceptions are changed. So I also am including the basic lesson plan. It just shows the NGSS standards and mathematical practices, but I'm using the 5E model to really explain everything that's happening in the activity. Thank you so much.